In previous video, we learned about MCP. We saw how AI agents communicate with external systems. But another important question remains. Suppose I ask ChatGPT, what's today's weather in Bangalore? How does ChatGPT know it should call a weather API? Or suppose I say, send an email to Rahul. How does ChatGPT know an email API is required? Did someone hard code this? Does the AI automatically know APIs? The answer is function calling. There are two different situations. Situation 1, the LLM already knows the answer. For example, we ask who invented Java. It simply generates text. No external systems are needed. Situation 2, the answer depends on live information, current weather, bank balance, flight status. Now the LLM cannot simply guess. Let's understand why. Suppose I ask what's the weather in Bangalore. Can the LLM answer? No. Why? Because weather changes every hour and the model was not trained on today's weather. If it guessed, it would be wrong. So instead of guessing, it needs help. This is very important. An LLM is not connected to the internet by default. It doesn't know your company's database or today's weather or your emails. Someone has to provide this information. This is exactly where function calling comes in. Instead of making up an answer, the model says, I don't know this information, but I know there is a function that can fetch it. A function is simply a piece of code, just like in Java. Example, get weather, send email, create meeting. Let's see the complete flow. The user asks, what's today's weather in Bangalore? The LLM first analyzes the question. It realizes I don't know today's weather, but I might know which function to call. It tells your application, I need output of getWeather city function instead of answering immediately. Your application executes the function getWeather. The weather API returns 28 degrees Celsius. Now the LLM has the latest data. It generates today's weather in Bangalore is 28 degrees Celsius with light rain. Notice something important. The LLM never called the weather API directly. Your application did. This is one of the biggest misunderstandings. People think ChatGPT itself calls APIs. That's not true. The LLM only says, I think this function should be called. Your application receives that request, runs the Java code, calls the REST API, returns the result. Then the LLM continues. If you are Java developer, get weather you know is just a normal method. Public weather get weather, that is taking argument city. There is nothing magical about it. The AI is not writing the weather code. It is only deciding when this method should be executed. Now the question is, how does the LLM know this function exists? Actually, we tell LLM. We define functions in our app. When our application starts, those functions are loaded in app. Now, when our application sends a request to the LLM, it also sends a list of available functions. For each function, we describe the function name, what it does, what parameters it accepts, what those parameters mean. Now the model understands which tools are available. We describe every function. Example here, getWeather is the name of function. Description is returns today's weather. Parameter is city. Now the model understands when to use it. This is important part. We don't send Java code to LLM. We don't send the implementation. We only send a description, also called a tool schema. The LLM reads this schema just like a human reads documentation. It now knows if someone asks about weather, I can use a tool named getWeather, and it needs a city argument. Your Java application converts this JSON into method parameters. The actual Java method stays inside your application. The LLM never sees this code. It doesn't know how you call the weather API. It only knows that such a tool exists. Another example, the model decides book restaurant function to be called. Arguments are restaurant, date, time, guest. Again, your backend executes everything. The same happens for emails. AI never sends emails. It requests send email function. Your backend actually sends it. Practical example with Spring AI. If you are using Spring AI, you might write something like a weather service that contains get weather method. Argument is city. When the application starts, Spring AI scans for methods annotated with @tool. It automatically creates the tool description schema and sends it to the LLM whenever a request is made. So the LLM learns there is a tool called getWeather. It takes one parameter called city and it returns the current weather. Notice that the LLM still does not execute the Java method. It only decides when that tool should be used. Modern AI agents often call multiple functions. For one user request, the agent may call 4, 5, or even 20 different tools. This is how complex workflows are automated. The LLM may decide to call one tool, receive the result, then decide another tool is needed. This process can repeat several times before producing the final answer. By now, you have learned about two important concepts, function calling and MCP. Many beginners think they are the same thing. They are not. Let's understand the difference. Suppose the user asks, "What's today's weather in Bangalore?" The LLM understands that it cannot answer from memory. It looks at the available tools and thinks, "I have a tool called getWeather. I should use that tool." This decision making is called function calling. Function calling answers one question: which tool should I use? Now another question arises. Once the LLM decides to use getWeather function, how does it actually communicate with the weather service? This is where MCP comes in. MCP provides a standard way for applications to expose tools. Instead of every application inventing its own format, everyone speaks the same protocol. This is how everything connects. The agent reasons, the LLM decides which function to call, MCP provides a standard communication mechanism, the external application performs the work. Now, interview question: what is function calling? A good interview answer is function calling allows an LLM to determine when an external function is needed, generate the required parameters, and let the host application execute the function before the model produces the final response. Let's summarize. The LLM does not directly interact with the outside world. It identifies when external information or an action is needed. It suggests the appropriate function and its parameters. Your application executes the function. The result is returned to the LLM. Finally, the LLM generates a complete response. So far, we have understood all the building blocks of modern AI system. In next video, we will stop talking about theory and start writing code. We will build our first AI application using Java and Spring AI. We will see how to connect an LLM, define functions, call tools, and generate real AI response inside a Spring Boot application. Thank you for watching.